Hi everybody, it's Mr. Oaks. So we're going to do some problems, some examples that involve equations that involve square roots and cube roots. Now, if you haven't already gotten comfortable with square roots and cube roots, I highly advise you to look at my video on how to do that, or, as I always suggest, go to Khan Academy. They have great videos there as well. So I have a few examples here that I want to go over. So let's get to it. So first off, we have a couple of basic equations. Solve for the variable. That's usually what you're going to get, is you're going to solve for the variable. So we'll take a look at the first one. The first one, b squared equals 64. Since it's a squared term, b squared, in order for us to get our answer, we need to just have b, the variable, completely by itself. So in order for us to do that, we have to take, in this case, the square root. We do that because it's b squared. So we're going to do the square root. I guess mine's done. Might as well stick with the b. Square root of b squared. And remember, when we do equations, we have to keep it balanced. So whatever we do to one side of the equation, we have to do to the other side of the equation. So I'm going to take the square root of 64. Now here's the thing, when we do square roots, there's actually a positive and a negative solution. So let's take a look. So we have b squared. Square root of b squared is just going to be b. 64, luckily, is a perfect square, so we're definitely going to have an answer. But here's the thing. There's two answers. The first answer is the one we automatically think of, 8 times 8, because 8 times 8 is 64. But remember, when we have a negative number times a negative number, we get a positive answer. So it'll also work that negative 8 times negative 8 equals 64, equals a positive 64. So in the case of a square root, we're actually going to have two answers. And what we do is we write this symbol. It's a plus over a negative. That tells us that the answer options are both positive and negative. So we get that the possible answers for b are a positive 8 or a negative 8. Okay? So that's one of the things you have to look for with square roots. Let's take a look at this. The second one, f to the third equals 125. So just like we did with the square root, we now have to undo the cubing. So we're going to now take the cube root. So we're going to take the cube root of f to the third, and we're also going to take the cube root of 125. So again, when we take the cube root of something that's being cubed, all we're left with is that something, which in this case is f. Now when we take the cube root, when we're multiplying something times itself, well, the only way we're going to get a positive answer is if the root is positive, right? Because a positive times a positive will still be positive. So when I look at this, my answer, because the number underneath the cube root symbol is positive, then my answer is going to be positive. And in this case, the cube root of 125 is just 5. Let's take a look at this cube root right here. Solve and explain the answer. We have here the cube root of negative 8 over 27. This time we have a negative under the cube root. And we can have that when it's a cube. Really, we can have that anytime it's an odd index. All right, we're taking the cube root, the fifth root, the seventh root, and so on. In this case, we can look at this and say, well, my answer, I'm going to take the cube root of 8 first. The cube root of 8 is 2. The cube root of 27 is 3. And then my answer is going to be a negative. Because when I have a negative 2/3 times a negative 2/3 times another negative 2/3, so that's negative 2/3 cubed. A negative times a negative is a positive, but then another negative makes it a negative answer. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So the reason my answer is a negative 2/3 is because when I have a negative times a negative times a negative, so a negative cubed, my answer is going to be cubed. And therefore, when I take the cube root of a negative number, my root will be negative. Okay? So now we have two more equations. We have solved the equation. X squared equals 79. So as we saw before when we had another equation that we were doing this square root, or we had x squared or something like that, we're going to take the square root because we have to get the variable completely alone. So we need to make that just x. So I'm going to do the square root of x squared, and whatever we do to one side, we have to do to the other. So square root of 79. Well, I can do the square root of x squared. It's x. But then I get to the square root of 79. And 79 is not a perfect square. You know, the perfect square before it is 64. It's close to 81, but it's not 81. So I kind of have an issue here. I can't really take the square root of 79. And most of the time, I want an exact answer. I don't want a decimal approximation. I don't want to go to my calculator and type it in and just kind of write, oh, I'm going to have to round it. I want an exact answer. Well, there's actually a simple solution for this, and that's to write this down. My answer is the square root of 79. That's the exact answer. So x squared equals 79, therefore x equals the square root of 79, whatever that number is. Somewhere close to 9, but not exactly. Okay? Same deal goes when we have a cube root. Solve the equation y cubed equals 115. So again, I need to go and I want the y cubed to just be y. So I'm going to take the cube root of y cubed in order to undo the cube. And I'm going to do the same thing to the other side because I need it to be balanced. So the cube root of 115. Again, the cube root of y cubed, the cube root and the cube are going to all cancel out, and all we're going to be left with is y. Cube root of 115, again, 115 is not a perfect cube. You know, you have 64, which is 4 cubed, and then you have 125, which is 5 cubed, but neither one of those is 115. So again, I want an exact answer. So the only thing I can do is rewrite the cube root of 115. And that's my answer. I can't do anything else. Again, I could try going to my calculator, but I'm only going to get a decimal approximation. And usually when we're solving an equation, we want an exact answer. This is the exact answer. This is the exact answer. let's finally take a look at a multi-part word problem. That paper took a long time to fall. So we have here, Tommy wants to fence off a I spelled off wrong. Tommy wants to fence off a part of his lawn to make a garden. The garden will be a square and has an area of 49 square feet. So the first part of the question says for us to write an equation to represent the area of the garden using S for the side length. And then we're going to solve the equation for S. So what we have to know is, well, if we're squaring, I'm going to try to use a little bit of color in here. I'm going to draw a square. And it's saying the side lengths are all S. And if we remember, when we find area of something that's a rectangle, which a square really technically is, it's length times width. Well, in this case we have side times side, and that's going to give us S squared, or side squared. So my equation is going to be S squared equals the area of the garden, 49. And then, now we're going to solve for S. We're going to take the square root of S squared, and we're going to take the square root of 49. Square root of S squared is S. And the square root of 49 is plus or minus 7. Now, we're dealing with a real world thing. So the question becomes, can we have a negative length? And in the real world, no, we can't. So we're going to get rid of the negative part of the answer. So our answer, S, is going to be 7 feet. So each side is going to be 7 feet long. The second part of this question, and this is usually what happens. They usually ask you to find out, oh, what's the length of the sides, and then they ask, well, how much is it going to cost? So the fencing costs $2.45 per foot. How much will he spend? Okay. So again, let's draw our square. It's always a good idea to draw some type of visual representation so you can kind of see, well, what's going on. Well, we know each side of this square is 7 feet long. And when we do a fence, it only goes around the outside. So I'm going to have 7 feet of fencing there, 7 feet of fencing there, 7 feet of fencing there, 7 feet of fencing there. And when we go around the outside, remember, that's called the perimeter. And all we're doing is adding up the sides. Well, in this case, all the sides are the same. So we can take a shortcut. And the shortcut is multiplication. So if we want to figure out how much fencing we need, which is just what is the length of fencing we need, well, I'm going to take my 7 feet and I'm going to multiply it by 4 sides. And those 4 sides, 7 times 4, gives us 28 feet of fencing that we're going to use. Well, that's not our answer because it wants to know how much will Tommy spend to make this fence for his garden. So then all we're going to do is we're going to multiply 28 by $2.45. So $2.45. times 28. Go to the calculator, tippy tappy, tippy tappy, tippy tappy tap, and we get an answer of $68.60. Make that 0 look like a 0 as opposed to almost a 6. And that's how you do that problem. So our final answer is, well, Tommy's going to spend $68.60 to put a fence around his new garden. I hope this is helpful. Remember, make sure to, if you have questions, to ask questions during class, or message me, or come to Extra Help. Good luck with the homework, and I'll see you in class. See ya!